Welcome to these gentle, soothing stories for sleep. I'm so glad you are here. Whether you are preparing to drift off to sleep, relaxing after a long day, or simply seeking a quiet companion, you have come to the right place. Tonight, we will embark on a journey of the imagination, a thought experiment that is at once terrifying and beautiful, designed to help us appreciate the profound stillness and stability of our world. We will ask the quiet question: what happens if Earth stops orbiting the Sun? Before we begin, I would love to know where you are listening from tonight, or how your day was. Please leave a comment below. Wherever you are, I hope you are feeling comfortable, relaxed, and ready to explore something gentle yet extraordinary. And if you find these soothing scientific journeys interesting, or pleasant, or even just wonderfully weird, please consider liking this video and subscribing to the channel. It helps more souls who are searching for peace find their way here. Imagine the feeling of being on a train, moving so smoothly and so quietly that you forget you are in motion at all. The cup of tea on your table is perfectly still. The gentle sway is a familiar comfort, and the world outside is a passing dream. Now, imagine that train braking with an impossible, instantaneous violence, going from hundreds of kilometers per hour to absolute zero in a single moment. It is a nauseating, catastrophic thought. Now, imagine that train is not a train, but the entire world. Imagine our planet, this beautiful blue sphere, suddenly ceasing its grand and silent journey around the Sun. In the first fraction of a second, the experience would not be one of astronomical change, but of a purely physical, intimate violence. Everything not fused to the planet's bedrock would become a projectile. Because while the Earth's orbit, its vast 94,000 km per hour sweep through space, has ceased, its spin has not. At the equator, the surface of our world is turning at over 1,600 km per hour. We, and everything around us, are carried along by this momentum, this inertia, just like the passenger on that smooth, fast train. When the train stops, the passenger does not. We would be thrown eastward at the speed of a supersonic jet. The air itself, a fluid ocean of gas, would for a moment be left behind, and then rush to catch up, creating a shockwave of unimaginable force. A single leaf, torn from the branch of an oak tree, would become a tiny green missile, shredding itself to dust in an instant. The oceans, vast and heavy, would slosh from their basins, creating a mega tsunami that would scour the continents clean. It would be a world erased by its own forward momentum, a planetary-scale car crash. But for our journey tonight, let us imagine a gentler, more magical cessation. Let us imagine that not only the orbit, but the spin, and all the chaotic inertia that goes with it, simply fades away. The world stops. It hangs in space, perfectly still, a silent bauble in the velvet dark. What happens now? The first true consequence begins not with a bang, but with a silent, invisible severing of a cosmic agreement. For our orbit is not just a path. It is a delicate and perpetual dance between two powerful forces. The first is the Sun's gravity, an immense and unrelenting pull, a cosmic string tying us to our star. The second is our own forward motion, our orbital velocity. Think of a ball on a string that you are swinging around your head. Your hand is the Sun, the string is gravity, and the ball is the Earth. The speed of the ball as it flies sideways is what keeps the string taut and prevents the ball from falling and hitting you. This is what physicists mean when they say an orbit is a state of continuous falling. The Earth is always falling toward the Sun, but because we are also moving sideways so incredibly fast, we always miss. It is a perpetual state of falling and missing, a beautiful equilibrium that has persisted for more than 4.5 billion years. In our scenario, that sideways motion is gone. The dance is over. The Earth is no longer falling around the Sun. It is now, simply, falling into it. The string that was once holding us in a graceful circle is now just pulling the ball directly to the center. The single, overwhelming force now governing our world is the Sun's gravity. And so, our planet, robbed of its momentum, has only one path left to it. a long, slow, and inescapable descent into the gravitational heart of our solar system. We have become a raindrop in a cosmic sky, poised to fall toward the distant fire. We float in the silent vacuum, and for a moment, nothing seems to have changed. The stars are where they have always been. The sun is a familiar warmth, but the clockwork of the heavens has broken. The silent, perfect balance we take for granted, the celestial rhythm upon which we have built our calendars, our crops, our biology, and our very consciousness, is gone. We trusted this cosmic predictability so deeply that we never even thought to question it, never suspecting the ferocious energies it so gracefully holds in check. The initial chaos we imagined, the world-scouring winds and waves, would have been a mere surface wound. The true consequence begins now, silently, invisibly, as our world begins a new and final journey. What would the first day of this new existence look like, with half the world now locked in perpetual sunlight and the other in an endless, freezing night? What happens when the sun ceases to be a traveller across our sky, and instead becomes a permanent, unmoving fixture, a great and terrible eye that never blinks? This is the first, most profound change to life on the now stationary Earth. The planet is divided into two new, absolute kingdoms, a realm of unending day and a realm of unending night. Let us drift down to the surface and feel this new reality. On the hemisphere facing the sun, the light is at first a comfort, but the comfort soon becomes a curse. The hours crawl by, and the sun does not move. It sits in the sky like a nail hammered into the zenith, or perhaps hangs low on the horizon, depending on where you are, a relentless furnace with no promise of sunset. The shadows, once dancing and transient things, are now stark, black, and permanent, etched into the landscape. The colour of the world begins to change. The gentle greens of forests and fields bleaching under the constant radiation, fading to a pale, ghostly yellow. The ground grows hot to the touch, and the air begins to shimmer with a heat that has no end. The very concept of a day, as a cycle of light and dark, has been erased, replaced by a single, eternal, scorching noon. On the other side of the world, the opposite fate unfolds. Here, the last light of the sun has already set, and it will never rise again. The darkness is absolute, a profound and bottomless blackness broken only by the cold, indifferent light of the stars. These stars are also fixed, a frozen tapestry of diamond-hard points that no longer wheel across the heavens. A chill settles into the air, a cold that feels different from a simple winter's night. It is a deep, penetrating cold that seems to emanate from the ground itself, as the hemisphere radiates all its stored warmth into the endless void of space. Frost begins to form not just on windows and leaves, but on everything, a crystalline sheath that grows thicker with each passing hour. The sounds of the night, the chirping of insects, the calls of nocturnal animals, begin to fall silent as the cold deepens, leaving only the whisper of a wind that is born of this new, impossible temperature difference. This hemisphere is now a world being slowly, inexorably, flash-frozen, a kingdom of eternal, star-haunted midnight. The science behind this dramatic separation is a simple matter of energy balance. Our planet's climate, and indeed its life, depends on a state of what is called thermal equilibrium. We are constantly absorbing energy from the sun in the form of radiation, and we are constantly radiating our own heat back out into space. The 24-hour rotation of the Earth is the key mechanism that balances this exchange. Like a slowly rotating chicken on a spit, our spin ensures that no single part of the planet gets too much heat or loses too much heat for too long. But now, the spit has stopped turning. The day side is now held to the fire without reprieve, absorbing far more energy than it can radiate away, leading to a runaway heating process. The night side is the reverse. With no incoming solar energy at all, it radiates heat away continuously, its temperature plummeting towards the absolute cold of deep space. Think of holding your hand near a campfire. You can do it for a moment, enjoying the warmth, but you cannot hold it there forever without getting burned. The day side is now held to the fire forever. Between these two impossible extremes, there would be a third kingdom, a thin ribbon of land and sea that wraps around the planet, forever caught in the moment of dawn or dusk. This is the terminator line, the boundary between light and shadow. One might imagine it as a place of refuge, a temperate zone of perpetual twilight, but it would be the most violent place on Earth. The air on the day side, superheated and expanding, would rise, creating a zone of low pressure. The air on the night side, supercooled and incredibly dense, would sink, creating a zone of immense high pressure. Air, by its very nature, flows from high pressure to low pressure, and so the terminator line would become the birthplace of the most ferocious, planet-spanning storm in history, a permanent hurricane, where the hot and cold halves of the world meet in a constant, violent battle. Life has always thrived in the gentle oscillations between extremes, in the rhythm of day and night, summer and winter. These cycles are not just markers of time, they are the very mechanisms of stability, the gentle breathing of a living world. Now that the breathing has stopped, our planet is left with only the extremes, a world of fire and a world of ice, locked in a forever war. This impossible temperature difference, this wound in the very fabric of the world's climate, would create a similar wound in the atmosphere itself. What kind of wind, we must ask, would be born from such a planet-wide fever? Have you ever stood on a coastline or on a high mountain pass and felt a strong gale push against you, a force so real and tangible it feels like a solid thing? It can steal the breath from your lungs and make you lean into it just to stay upright. Now, try to imagine a wind that is not born of a local storm, but of the entire planet's agony. A wind that carries with it the heat of an oven and the abrasive power of a sandblaster. A wind that never, ever stops. This is the new reality of the air on our stationary Earth. The gentle atmosphere, the breathable, life-giving ocean of gas we move through without a thought, has now become a monster. The process begins simply, driven by the stark division of the world. On the sun-scorched day side, the air becomes superheated. It expands, becoming light and buoyant, and rises in a vast, planet-sized column. On the frozen night side, the air becomes supercooled. It contracts, growing incredibly dense and heavy, and sinks towards the frozen ground. This creates a difference in atmospheric pressure between the two hemispheres of an almost unimaginable scale. And in the language of physics, a pressure difference is the engine of wind. The result is a global, perpetual superstorm. Air from the high-pressure cold side rushes toward the low-pressure hot side, not as a breeze or a gale, but as a constant, horizontal hurricane. At the surface, frigid air from the dark side would pour across the twilight line, a torrent of extreme cold blasting into the hot hemisphere. High above, in the upper atmosphere, the hot, rising air from the day side would spill over and race toward the night side to cool and sink again, completing a vast and catastrophically violent convection cycle. The Earth has become a simple heat engine, like a pot of water boiling on a stove, but with air as its fluid and a star as its flame. The sound would be the first thing to overwhelm the senses. Not the gusting or howling of a normal storm, but a single, continuous, planet-shaking roar. The winds would quickly exceed the speed of sound, which is about 1,236 kilometers per hour at sea level. This means the entire world would be subject to a constant overlapping barrage of sonic booms, a physical vibration that would be felt in the very crust of the planet. The wind would pick up dust, then sand, then pebbles, then boulders, turning the air itself into a relentless abrasive force that would grind down mountains and scour canyons over the course of days. We can understand this by thinking of a simple balloon. The air inside is at a higher pressure than the air outside. When you open the neck of the balloon, the air doesn't gently drift out. It rushes out in a powerful stream. We have turned our world into a planetary version of this, with one hemisphere constantly being inflated with heat and the other being deflated by cold. The flow between them is inevitable and tremendously powerful. This is convection, the same process that stirs your soup as it heats, but scaled up to a terrifying degree. This great wind would be the planet's last, desperate attempt to find balance, to move the immense heat from the sunlit side to the frozen dark side. But it would be a futile effort, a circulation of pure destruction. The hot winds would bring no relief to the night side, only a brief, scorching blast before the cold overwhelmed them. And the cold winds would bring no comfort to the dayside, evaporating and heating up long before they could cool the searing landscape. We think of the air as gentle, as something close to empty space. We cherish its stillness and its soft breezes. But this thought experiment reveals the truth. Our atmosphere is a reservoir of immense and restless energy, a fluid ocean above us whose tranquility is a fragile gift. It is held in a delicate, life-giving balance only by the constant, gentle turning of our world. And what of the other fluid ocean, the one of water that covers more than 2/3 of our world's surface? The waters are far heavier and denser than the air, and they would not remain still in the face of such a global cataclysm. They too must respond to the new reality of a world half frozen and half on fire, and their response would be as dramatic and as final as the fury of the wind. Think of the sound of the ocean as it is meant to be. The gentle, rhythmic lapping of waves on a sandy shore, a sound so peaceful it is woven into our meditations and our dreams of tranquility. Now, hold that sound in your mind and listen for a different one. A sound that begins as a low hiss, like a billion kettles all coming to a boil at once, and grows into a thunderous, rolling roar. It is the sound of an entire ocean turning to steam. This is the fate of the waters on the day side of our unmoving Earth. Under the relentless, stationary sun, the vast blue plains of the Pacific, the Atlantic, and the Indian Oceans begin to warm. As we have seen, water is a remarkable substance. It has a very high specific heat capacity, meaning it can absorb a tremendous amount of energy without its own temperature rising very much. This property is a blessing for our stable climate, as the oceans act as a giant thermal buffer, smoothing out temperature extremes. You can see this yourself by comparing a cast iron pan to an aluminum one on the stove. The heavy iron takes much longer to heat up. The oceans are like a pan of unimaginable size and thickness. For a time, they would resist. But even their immense capacity for heat is not infinite. First, the surface of the dayside ocean would begin to steam, releasing a thick, white fog that would soon cloak the entire sunlit hemisphere. This fog would itself trap more heat, accelerating the process. Soon, the surface waters would reach 100 degrees Celsius, and the boiling would begin. Not a gentle simmer, but a violent, churning, rolling boil on a scale of millions of square kilometers. Immense clouds of scalding steam would billow into the tortured atmosphere, joining the great global winds. Any life in the upper layers of the ocean would be extinguished instantly. As the process continued, the boiling would extend deeper and deeper, a slow-motion catastrophe that would, over time, boil the sunlit oceans completely dry, leaving behind vast, sterile plains of salt and mineral crusts under a crushing atmosphere of steam. On the night side, the opposite tragedy unfolds in the silent, star-haunted dark. Here, the oceans are radiating their heat away into the void. The effect of salt in the seawater acts as a natural antifreeze, lowering its freezing point from 0 degrees Celsius to approximately -2 degrees Celsius. But this small grace only delays the inevitable. Soon, the surface of the nightside oceans would reach this temperature. A thin, glassy skin of ice would form, silencing the last of the wind-whipped waves. This skin would grow thicker with every passing hour. Unlike boiling, which is a violent and obvious process, freezing is a quiet, creeping one. The ice layer would expand downwards, meter by meter, a slowly descending ceiling of crystal that would entomb everything below it. The great ecosystems of the deep, the strange and beautiful creatures of the midnight zone, would find their world shrinking. The pressure would build, and the water below the ice would become supercooled, a liquid colder than its own freezing point, a strange and unstable state before the final solidification. Eventually, the ice would be kilometers thick, a single, unbroken sheet of planetary ice armoring the entire dark hemisphere. The oceans, the cradle of all life on Earth, would have met their dual fates. On one side, they are transformed into a violent, gaseous inferno of steam. On the other, they are locked into a solid, crystalline tomb. We are beings of water, born from the primordial seas millions of years ago. Our bodies are mostly water. Our lives depend on its constant, gentle cycle. To watch the oceans die in these two extreme ways is to watch the death of our own origin story, to see the fundamental element of life become a planetary scale weapon. But all of this heating and freezing, this roaring wind and hissing steam, is just the local weather of our new, terrible home. We have forgotten the larger picture. While the Earth is tearing itself apart from the inside, it is also moving. It is on a journey. Where has our silent, downward fall taken us so far? What if you knew, with absolute and unimpeachable certainty, the exact date and time your world would end? Not as a prophecy or a premonition, but as a simple, cold calculation of physics, as undeniable as the sun in the sky. This is the new psychological reality for anyone who might have survived the initial chaos on our now falling Earth. From the surface, the world is a hell of wind and steam and ice, a place of constant violent reaction. But if we pull our perspective away, out into the silent, cold vacuum of space, the true journey reveals itself in a much quieter, more serene, and somehow more dreadful way. We see the blue marble, now scarred and half-shrouded in a ghostly white veil of steam, hanging silently against the backdrop of the fixed stars. It seems motionless at first, a lonely ornament in the dark. But it is not motionless. It is falling. Silently, inexorably. It has begun its long pilgrimage into the heart of the sun. The change would be imperceptible at first. Day 1, Day 2, Day 3, the sun would look no different. But a week into the fall, an astute observer would notice that the solar disk was just a fraction of a percent larger in the sky. 2 weeks in, the change would be undeniable. The sun is growing. Fatally. This journey is governed by one of the most fundamental and beautiful laws of our universe. Newton's law of universal gravitation. It tells us that the force of attraction between two objects, in this case, the Earth and the Sun, is proportional to their masses and gets stronger as the distance between them gets smaller. When we were in our stable orbit, this law described the tether that kept us in our circular dance. Now, it is the law that describes the rope pulling us to our doom. Using this law, physicists can calculate the time it would take for the Earth to fall into the Sun from a stationary start. The problem can be imagined as the Earth tracing out a new orbit, a tremendously long and thin ellipse that is perfectly flattened, with its starting point at our home orbit and its end point inside the Sun itself. The journey time, from the moment our motion ceased, comes out to be approximately 64 days. Just over 2 months. 64 days to watch the sun grow from a familiar, life-giving star into a monstrous, world-ending furnace. Let us turn away from the physics for a moment and consider the human heart, the human mind. How would we, as a species, process an inescapable, collective 64-day death sentence? What would happen to our art, our economies, our laws, our love? Would we descend into chaos? Or would we find a strange new kind of unity in the face of a shared, absolute end? Perhaps there would be a great turning towards philosophy and religion, a desperate search for meaning in the final act. Perhaps great works of art would be created, messages in bottles for a universe that would never receive them. Or perhaps we would simply turn to each other, finding solace not in grand gestures, but in the quiet company of those we love. As we watch the sky grow brighter, we live our lives by human timescales, the passing of days, the turning of seasons, the marking of years. But we are, and have always been, subject to cosmic timescales that are utterly indifferent to us and our concerns. This 64-day journey reveals our true status. We are passengers on a small, fragile rock, subject to immense and ancient laws we can understand but never hope to defy. Our final 2 months would be the ultimate lesson in humility. And as our pilgrimage continues, as we cross the orbital path of our sister planet, Venus, the sun is no longer a familiar friend at all. It has become a tyrant. What does its ever-intensifying glare do to the very fabric of our world's atmosphere? A warm blanket on a cold night is a deep and profound comfort. It is a shield against the dark, a small, personal world of warmth and safety. But what if that blanket were made of scalding steam, growing heavier and hotter with each passing moment, a blanket you could never, ever take off. This is what has become of Earth's atmosphere. As our world falls deeper into the sun's embrace, and as the oceans on the day side continue their violent boiling, the sky transforms. From the surface, any view of the cosmos is now completely gone. The world is permanently encased in a thick, featureless, and oppressive white ceiling of cloud and steam. There is no sun, no moon, no stars. There is only this luminous, suffocating blanket. The atmospheric pressure, which at sea level we are used to as a gentle, unnoticed weight, begins to mount catastrophically. The sheer mass of all that vaporized ocean water presses down, becoming a crushing physical force. The air grows thick, wet, and incredibly hot, not like a humid summer day, but like the inside of a planetary pressure cooker. The sound is a constant, deafening roar, a blend of the supersonic global winds and the thunder of a permanent, worldwide electrical storm generated within the churning, vaporous atmosphere. This planetary fever is the result of a process known as a runaway greenhouse effect. The basic mechanism is something we experience in a small way every time we get into a car that has been sitting in the sun. Sunlight, which is mostly visible light, passes easily through the car's windows and warms the seats and the dashboard. Those warmed surfaces then radiate their own heat back, but they do so as infrared radiation, a different wavelength of light. The windows are not as transparent to infrared light, so a lot of that heat gets trapped inside, and the car gets much hotter than the air outside. Our atmosphere has its own windows and its own heat-trapping gases. While we often speak of carbon dioxide, water vapor is, molecule for molecule, an incredibly potent greenhouse gas. As the sun boils Earth's oceans, it is pumping quintillions of tons of water vapor into the air. This vapor traps the outgoing infrared heat from the planet's surface, which in turn heats the atmosphere and the surface even more, which boils the oceans even faster. This is the terrifying core of the problem. A positive feedback loop. It is a one-way street of ever-increasing temperature. More heat leads to more steam, which leads to more trapped heat, which leads to more steam still. It is a runaway cycle with no off switch. And this is not merely a theoretical fancy. We have a real-world example of this exact process in our own solar system. Many planetary scientists believe this is precisely what happened to our sister planet, Venus. It is possible that billions of years ago, Venus was a temperate world, perhaps with liquid water oceans much like Earth's. But being slightly closer to the Sun, it reached a tipping point. A runaway greenhouse effect took hold, boiling its oceans and creating the thick, dense carbon dioxide and sulfuric acid atmosphere that smothers it today. The result is a surface temperature of over 465 degrees Celsius, hot enough to melt lead, and a surface pressure 90 times greater than Earth's. Our beautiful blue and white Earth is now following in its sister planet's footsteps, wrapping itself in a shroud of its own boiled oceans, becoming a second Venus. We speak of planetary balance as if it is a permanent, guaranteed state. But this vision shows us that a world can be pushed past a point of no return. It is a quiet, cosmic cautionary tale about how a small change, amplified by feedback loops over time, can lead to a complete and irreversible transformation from a garden into an inferno. Under this oppressive, crushing blanket of steam, surely all life on the surface has long since perished. But does life have any final hiding places? Any last, desperate refuges in the deepest, darkest corners of our dying world? In a world where the surface has become an uninhabitable hell, a realm of crushing pressure and scalding steam, where could the very last heartbeat possibly be found? To find it, we must take a journey downwards, away from the memory of the sun, into the deepest and most extreme environment our planet has to offer. We descend through the boiling, churning ocean, a column of water miles deep. The pressure builds relentlessly, a physical weight that would crush any submarine we have ever built into a twisted ball of metal. The light from the luminous, steam-filled sky fades, and we enter a realm of absolute and eternal blackness. Here, on the ocean floor, 4, 5, maybe even 6 kilometers down, we find the last sanctuary. It is a landscape of volcanic plains and deep trenches, and rising from the seafloor are strange, chimney-like structures made of precipitated minerals. These are hydrothermal vents, fissures in the Earth's crust, where superheated, chemical-rich water from the planet's interior erupts into the freezing, high-pressure darkness of the abyss. And around these vents, life is flourishing in a final, defiant outpost. Great clusters of ghostly white tube worms, some several feet long, sway in the chemical currents, their bright red plumes filtering nutrients from the water. Blind white crabs scuttle across the rocks, and thick, shimmering mats of ancient bacteria coat every surface. It is an entire ecosystem, a bustling city of life that is completely and utterly oblivious to the sun. The secret to this deep-sea metropolis is a process called chemosynthesis. All of the life we are familiar with on the surface depends, ultimately, on photosynthesis, the process by which plants use the energy of sunlight to create sugar from carbon dioxide and water. Our entire food web is built upon this foundation of solar energy. But here, in the permanent dark, life has found another way. The bacteria that form the base of this food chain are not powered by sunlight, but by chemical energy. They metabolize the noxious, sulfur-rich compounds pouring from the hydrothermal vents, chemicals like hydrogen sulfide, the same compound that gives rotten eggs their smell. They perform a kind of chemical magic, turning poison into life, creating energy in a place where no ray of light has ever reached. The other animals here live on these bacteria, or on other animals that eat the bacteria. They are living proof that life does not strictly need a sun, only a source of energy. These organisms are the ultimate survivors, known to science as extremophiles, which translates from the Greek as lovers of extremes. They thrive in conditions that would be instantly lethal to us. Pressures hundreds of times greater than the surface. Temperatures ranging from near freezing to well over the boiling point of water right at the vent openings. And a chemical bath that would be toxic to almost any other living thing. But even this final, remarkable sanctuary is living on borrowed time. Its resilience, born of independence from the sun, cannot save it from the planet's own death. As the Earth continues its fall, the inferno on the dayside heats the entire planet, not just its surface. This heat slowly conducts through the crust, and the geothermal gradient, the rate at which temperature increases with depth, begins to shift. The very water that nurtures this ecosystem will grow hotter and hotter until it is no longer life-sustaining. Eventually, as the whole of the oceans heat up, the pressure and temperature will become so great that the water will transform into a strange state of matter known as a supercritical fluid, something that is neither a liquid nor a gas, but a powerful solvent that will scour these last outposts of life from the rock. Life, it seems, does not want to die. It will cling to every available niche. It will adapt to the most hostile environments imaginable, and it will persist against impossible odds. This final, flourishing darkness, powered by the Earth's own inner fire, is a silent and beautiful testament to the sheer, stubborn, elemental force of biology. But life is just a thin, precious film on the surface of our world. What of the planet itself? The rock and the metal that form its great body. As the inferno grows, the very ground, the symbol of all that is solid, will begin to weep. We place our trust in the ground beneath our feet. It is the very definition of that which is solid, stable, and permanent. We build our homes, our cities, and our civilizations upon a foundation of rock, believing it to be eternal. But what happens when the planet develops a fever so high that the stones themselves begin to melt and flow like water? As our world is carried ever closer to the sun, the dayside, already scoured clean of its oceans and atmosphere, is now subjected to temperatures that beggar the imagination. The surface of the Earth, which has been baking for weeks, begins to emit its own light, glowing a dull, ominous cherry red. Then, in patches, that glow brightens to orange, then to a brilliant yellow-white. The surface begins to soften. First, the more fusible metals in our infrastructure would go. Lead pipes would slump and pool. Then the aluminum frames of buildings and aircraft would vanish into shimmering puddles. But soon, the very rocks themselves begin to surrender. Granite, the hard, crystalline rock that forms the core of our continents, has a melting point of over 1,200 degrees Celsius. The day side of the Earth now soars past this temperature. The effect is a vision from a surrealist painting. Mountain ranges, those great symbols of geological time and unyielding permanence, begin to sag. Their sharp, majestic peaks slump and round off, like wax statues left too close to a fire. Glaciers of molten rock, of liquid basalt and granite, begin to crawl down their slopes, carving new, fiery valleys. The continents themselves, the great tectonic plates upon which we lived, lose their integrity. Their edges dissolve, and they slowly break apart, not with the geological slowness of continental drift, but with a horrifying speed. The day side of the Earth is becoming a single, global ocean of magma, a sluggish, incandescent sea, thousands of kilometers across. Before this great melting, however, another process would wreak havoc. As the rocks heat up, they expand, a process called thermal expansion. This would create stresses in the crust, on a scale that has never been experienced in the planet's history. These stresses would trigger the largest earthquakes imaginable, not quakes that are measured as a 9 or a 10 on the Richter scale, but quakes that would register in the 12s or 13s, releasing enough energy to physically crack the lithosphere. These planetary convulsions would, in turn, trigger volcanic eruptions on a scale that dwarfs any supervolcano in our past, a final, violent outgassing of the planet's tormented interior. And there is another, more subtle consequence. Deep within the Earth, the churning of the liquid iron outer core generates our planet's protective magnetic field. This field, invisible to our eyes, extends far out into space, shielding us from the most harmful radiation of the solar wind. This internal dynamo, however, is a delicate process, dependent on a specific thermal balance. The immense influx of heat from the outside would disrupt the convection currents in the core, causing this magnetic shield to flicker and fail. Without it, the solar wind, which is growing ever stronger and denser as we approach the sun, would blast the planet directly, stripping away the last vestiges of our steam-shrouded atmosphere with ferocious efficiency. We build our world on stone because we believe it is forever. This vision shows us that even stone is impermanent. Everything we consider solid and real, from a simple pebble to a great mountain, is merely a temporary state of matter, a collection of atoms bonded together in a particular way. And all of those bonds are conditional, waiting only for enough raw energy to be applied, to break them apart and allow them to flow away. As the Earth itself is unmade, the light from the sun is transforming from a source of energy into a pure, destructive force. How does this overwhelming, tyrannical light change the very color and fabric of reality itself? We crave the light. We are creatures of the day. Our eyes evolved to gather in the gentle photons of a yellow sun. Light, for us, is synonymous with clarity, with knowledge, with safety, and with life itself. We use it to see the faces of those we love and to navigate the world around us. But what if the light became so absolute, so overwhelmingly bright, that it was the very last thing you ever saw? As the molten Earth continues its 64-day fall, it is now deep inside the orbit of Mercury, and the sun is no longer a disk in the sky. It has become the sky itself. It is a monstrous, terrifying wall of fire that fills a huge portion of the heavens, a furious, searing, blue-white furnace that has erased all other celestial objects. On the day side of the planet, the very concept of a shadow has ceased to exist. Every crack, every crevice, every atom is illuminated from a million different angles by the sheer size of the solar surface. There is no place to hide. The very idea of color has been bleached away into a uniform, blinding, painful glare. Any object that might have survived the initial melting is now not just melted, but instantly vaporized by the sheer intensity of the light falling upon it. The surface of the molten planet boils under this photonic assault, not with the heat of conduction, but from the direct, unimaginable energy of pure light. The physics behind this terrible transformation is governed by a simple but powerful rule known as the inverse square law. It tells us that the intensity of light does not decrease in a simple, linear way with distance, but with the square of the distance. This means if you are twice as far from a light source, it is 4 times dimmer. If you are 10 times as far, it is 100 times dimmer. But this law works in reverse as we get closer. Halving our distance to the sun makes its light 4 times more intense. Halving it again makes it 16 times more intense. It is a law of exponential return, and our planet is now on the agonizingly steep end of that curve. A little closer now means a lot brighter. Imagine the warmth of a bonfire on your face from a few meters away. Now imagine stepping to within a few inches. The energy difference is not just more, it is of a different quality altogether. It is the difference between warmth and incineration. Furthermore, the light we see is only a tiny fraction of the energy the sun pours into space. The sun is a nuclear furnace, and its radiation spans the entire electromagnetic spectrum. There are radio waves, microwaves, infrared, and the visible light our eyes can see. But there are also the high-energy photons, ultraviolet, X-rays, and even gamma rays. At our normal, safe distance of 150 million kilometers, our atmosphere and magnetic field filter out the worst of this high-energy radiation. But here, in the sun's inner sanctum, we are being blasted by a torrent of it. This is not the light that powers photosynthesis. It is the light of sterilization. Radiation so powerful that it tears electrons from atoms and shatters the bonds of any molecule it strikes. It is this radiation that is helping to vaporize the molten surface of our world. And there is one final, subtle effect. Light itself, though it has no mass, has momentum. It can exert a tiny, physical pressure. We call it radiation pressure. In our everyday lives, it is a force so small as to be completely unnoticeable. But the amount of light now striking the Earth is so immense that this pressure has become a significant force, a kind of stellar wind that is physically pushing against the planet, helping to blow away the atoms that have been vaporized from its surface. We have always seen light as a metaphor for good, for truth, for life. But like every great force in the universe, it is impartial. In the right dose, it is the gentle engine of all biology. In this catastrophic overdose, it is a sterilizing, scouring, vaporizing blowtorch that erases everything it touches. While the day side is being unmade by this tyranny of light, the night side has remained a realm of absolute cold and star-filled darkness. But even that fortress of shadow cannot last forever. How does the fire from the front finally find its way to the back? You can hide from the light. In the shadow of a rock, in the darkness of a cave, or on the far side of a world, you can find a refuge from its glare. But can you hide from the heat that soaks through the very heart of the world itself? For weeks, the night side of our planet has been a bastion of profound cold and deep quiet. The only light has been the cold, fixed light of the distant stars. The great, miles-thick sheet of ice that now covers the frozen oceans has been a silent, crystalline shield. But now, a change begins to happen. Not from above, but from below. Deep cracks begin to form in the planetary glacier, not from any impact or external force, but from a strange, geothermal warmth that begins to pulse upwards through the planet's crust. The ice groans, a sound that travels for thousands of kilometers through the solid surface. Great sections of it begin to melt, forming vast, temporary lakes of slush and water on the surface of the glacier, which quickly refreeze in the absolute cold of the nightside air. But the heat from below is relentless. The underside of the great ice sheet begins to dissolve, and soon the frozen ocean becomes a warm sea, then a hot sea, and then a boiling one, all taking place under a sky of unchanging, silent stars. The scientific principle at work here is one we are all familiar with: conduction. Leave a metal spoon in a cup of very hot tea, and you will notice that after a minute, the handle of the spoon, which is not touching the tea at all, has become warm and then hot. Heat is the vibration of atoms, and these vibrations can travel through solid objects. The atoms in the hot end of the spoon jostle their neighbors, who jostle their neighbors, and so on, until the energy has been transferred all the way to the cold end. The rock and iron of our planet, while not as efficient a conductor as a metal spoon, still obey the same law. The day side of the Earth is being submerged in an ocean of energy, and that energy is being conducted, slowly but inexorably, through the mantle and the core to the far side of the planet. For a time, The sheer mass of the Earth acts as what engineers call a heat sink. It absorbs the colossal influx of energy without its overall temperature rising too quickly, just as a large block of ice can absorb the heat of a summer day for a long time before it is fully melted. But every heat sink has a finite capacity. Eventually, the entire body of the planet becomes saturated with this thermal energy. The temperature throughout the Earth's interior rises past the melting point of all its constituent materials. The very idea of a hot side and a cold side begins to fade, not because the night side is being warmed by the sun, but because the entire planet is now glowing with its own internal heat. The final sanctuary of the night side was never a true refuge. It was merely an illusion created by the time it took for the heat to travel through 30,000 kilometers of rock and iron. Now, that time has run out. The process of equalization is complete. Pulling our perspective back out into space, we would no longer see a world of two faces, one bright and one dark. We would see a single, uniform, glowing ball of incandescent magma, a tiny, temporary star, shining with its own furious, borrowed heat. We think of escape as moving from a dangerous place to a safe one. But when the very ground you stand on becomes the source of the threat, there is no direction in which to run. The end comes not as an attack from the outside, but as a slow, creeping transformation from within. The Earth is now a molten, self-luminous planet, racing towards its final doom. But it is not alone. Its faithful, silent companion, the Moon, has been sharing this terrible journey, a silent witness in the sky. What is its fate in this ever-growing inferno? Take a moment and look up at the Moon in your mind's eye. See its gentle silver light, its familiar face of craters and seas, a constant and reassuring presence in our night sky. It is a symbol of quiet beauty, of mystery, of the rhythm of the tides, and of the dreams of poets and astronauts. It has been the silent witness to our entire history, from the first flicker of life in the oceans to this very moment. Now, hold that image, that feeling of constancy and peace, and watch as it is torn apart. The perspective of our journey now shifts to the surface of the Moon itself. From the silent, grey dust of the Sea of Tranquility, the view is apocalyptic. The sun is a monstrous, terrifying furnace that dominates the black sky. And hanging in that sky is the Earth. It is no longer a familiar blue and white marble. It is a terrifying, glowing orb of molten rock, a malevolent eye radiating immense heat. As the Earth-Moon system continues its plunge inward, it is about to cross an invisible line in space, a gravitational kill zone. As it does, the sun's immense gravity begins to exert a terrible power upon the Moon. The pull is stronger on the side of the Moon closer to the sun and weaker on the far side. This difference, this gravitational gradient, begins to stretch the Moon. Great cracks, thousands of kilometers long, appear on its surface. The entire satellite begins to deform, to elongate, like a piece of cosmic clay being pulled apart by vast, invisible hands. The Moon is about to meet its end at a place defined by physics as the Roche limit. The Roche limit is the distance from a large celestial body, like the Sun, within which a smaller body, like our Moon, that is held together only by its own gravity, will be disintegrated by the tidal forces of the larger body. We can think of tidal forces by imagining a long rubber band. If you pull on both ends, the entire band moves. But if you hold one end still and pull very hard on the other, the band stretches. This is what the Sun's gravity is doing to the Moon. It is pulling so much more powerfully on the near side than the far side that it overcomes the Moon's own gentle gravity, the very force that has held it together in a sphere for billions of years. The cracks on its surface widen into vast canyons, and the Moon shudders, not from an impact, but from its own internal tearing. It is being unmade from the inside out. Finally, it can hold together no longer. The Moon shatters, not in a fiery explosion, but in a silent, graceful, and terrible disintegration. It breaks apart into a collection of smaller moonlets, and then into a cascade of billions of rocks and boulders and dust particles, a cloud of what was once our steadfast companion. These shattered pieces would not simply fly off into space. They would be captured by the gravity of the nearby, molten Earth. They would spread out, forming a temporary, brilliant ring of debris around our dying planet. For a few short hours, the Earth would be a spectacle of terrible beauty, a glowing, molten world adorned with a shimmering silver ring, composed of the last remnants of its lost moon. It would be a short-lived, cosmic funeral wreath, a final, beautiful elegy for our lost companion, before the ring itself is vaporized and consumed by the ever-growing sun. The moon has been our mirror in the sky, our muse for art and science, the anchor of our planet's tilt, the puller of our oceans. Its destruction is not just a physical event. It is the erasure of a part of our collective soul. It represents the loss of the other main character in our sky, the final severing of our connection to a stable and predictable cosmos. Our world is now a molten, ringed planet, a vision of hell, racing towards its doom. It is now about to enter the sun's own atmosphere. What does it even mean to fly through the outer layers of a star? We think of space as being empty, a perfect vacuum stretching between the worlds. And for the most part, it is. But the closer you get to a star, the more you realize that you are not in an empty void, but in an invisible, churning, and incredibly energetic ocean. The molten, ringed Earth has now crossed another threshold, leaving what we think of as empty space and entering the sun's own outer atmosphere. This is a strange, ethereal, and ghostly realm known as the corona. From the surface of our molten world, the experience would be bizarre. The corona is a place of strange and contradictory physics. It is a vast, wispy halo of plasma, the fourth state of matter, where the heat is so intense that electrons are stripped away from their atoms. And the temperature of this incredibly thin plasma is millions of degrees Celsius, paradoxically, far hotter than the visible surface of the sun below it. Yet, because the plasma is so incredibly diffuse, with its particles being very far apart, it does not glow with the same intensity. The Earth is now flying through this ghostly superheated fog, and the primary sensation would be that of a constant, omnidirectional sandblasting by high-energy particles. This constant stream of particles is the solar wind. The sun is always shedding its own substance, breathing a constant flow of charged particles, mostly protons and electrons, out into the solar system. On our normal Earth, our powerful magnetic field creates a protective bubble around us, the magnetosphere, which safely deflects the vast majority of this solar wind. But in our scenario, the magnetic field has long since failed, and we are now in the very heart of the storm, closer to the source than any planet. This solar wind, which was once a gentle cosmic breeze, is now a relentless, erosive force. It strikes the molten surface of the Earth and physically blasts away atoms and molecules, stripping the planet layer by layer, carrying its substance away on a current of stellar breath. In this extreme environment of very high temperatures and very low pressure, the material of our world is not just melting, it is sublimating. Sublimation is the process where a substance transitions directly from a solid or liquid state into a gas, bypassing the intermediate phase. We see this on Earth with dry ice, which is frozen carbon dioxide that turns directly into a gas without ever becoming a liquid. The molten rock and iron of Earth are now doing the same, its surface fizzing away into space, evaporating under the combined assault of the intense light and the abrasive solar wind. We are now in the realm of the sun itself. The very boundary between what is the planet and what is the star has begun to blur. The Earth is no longer a distinct object, a visitor traveling through the solar system. It is being actively and violently incorporated into the sun's own environment. Its matter is being claimed, stripped away, and carried off by the solar wind, a process of dissolution that begins long before the final impact. The planet is becoming a ghost of itself, a celestial spectre shedding its own essence as it approaches its final destination. It is a slow and steady erasure, a process that turns our solid world into a diffuse cloud of incandescent vapor. The planet is evaporating, but its journey is not yet over. Its dense, metallic core, the heaviest part of our world, still remains for a little while longer, a heart of iron plunging ever deeper into the fire. The forces acting upon this remnant are now becoming so extreme that they will do more than just melt or vaporize it. They will deform it into a shape that signifies the world's final, ultimate surrender. What is the final shape of a falling world? We think of planets as perfect spheres, or very nearly so, their immense gravity pulling them inwards into the most stable and efficient shape possible. A sphere represents unity, strength, and wholeness. It is the shape of a world held together against the void. But as our molten planet gets agonizingly close to the sun's visible surface, the photosphere, its own gravity, is no longer the most powerful force acting upon it. The same tidal forces that shattered our moon into a temporary, beautiful ring are now acting upon the Earth itself, and they are doing so with an intensity that is difficult to comprehend. The glowing, molten sphere begins to stretch. The process is slow at first, the planet elongating slightly along the axis pointing toward the sun, becoming what is known as a prolate spheroid, the shape of an egg. It is a subtle deformation, but it is the beginning of the end of the Earth as a single, coherent body. The shape becomes more and more extreme as we fall ever closer. The egg becomes a teardrop, a planet drawn out into a long, incandescent streamer of matter, its pointed end reaching out towards the sun, a final, silent gesture of surrender to its own demise. This final, terrible transformation is the result of that same gravitational gradient we have explored before. The pull of the sun's gravity on the side of the Earth that is nearest to it is now so much unimaginably stronger than the pull on the far side that it overcomes the planet's own immense self-gravity. The force trying to hold the world together in a sphere has been defeated by the force trying to tear it apart. We have now been carried deep inside our own Roche limit relative to the sun. This is the point of no return for our world's physical integrity. It can no longer hold itself together. Imagine pulling on a drop of honey. For a moment, its surface tension holds it in a sphere. But as you pull your fingers apart, it stretches, forming a thin strand between them before it finally breaks. Our planet is now that drop of honey, and the sun's gravity is pulling it into an impossibly long and thin filament of molten rock and iron. This stretching is the final act of the planet as a unified object. It is a process of planetary dismemberment that happens not through a violent collision, but through a silent, inexorable, and deeply powerful stretching. Looking on from a distance, we would see the Earth transform from a glowing point of light into a short, bright line, a streak of fire against the much larger fire of the sun. The teardrop shape is the last moment of a recognizable world. From this point, it will be pulled apart entirely, ceasing to be a planet in any sense of the word, and instead becoming a river of what was once our home, a torrent of incandescent matter flowing into the sun. A sphere is a shape of balance and self-possession. It is the form that matter naturally takes when its own gravity is the dominant force. To see that perfect sphere pulled and distorted into a teardrop is to witness the ultimate defeat of cohesion, the final, visual surrender of a world's internal strength to a power so much greater than its own. The teardrop is about to break. A stream of matter that was once mountains and oceans, that was once the ground that held our cities and the iron that formed our planet's heart, is now pouring into the sun. What happens at that final moment of contact, when our world finally touches the face of its star? What sound does a planet make when it dies? In the vast, silent theatre of space, there is no air to carry a sound wave, no medium to transmit a final, thunderous crash. The end comes not with a bang, but in an overwhelming absolute silence. The long, molten teardrop that was once the Earth has finally stretched to its breaking point. A stream of liquid rock and iron, thousands of kilometers long, detaches and begins its final plunge. It touches the photosphere, the visible surface of the sun. But there is no grand explosion, no cosmic spectacle of concussive force. Instead, the moment of impact is more like pouring a small stream of water into a vast, churning ocean. The material of our world, the iron from its core, the silicon from its mantle, the oxygen and carbon that once formed its life and atmosphere splashes into the sun. The impact creates a brief, brilliant flare, a ripple on the surface of an ocean of fire that is brighter than the surrounding plasma for just a few moments. It is a flash of light that contains the last, compressed story of our planet's chemical history. Then, it is gone, swallowed by the roiling convective currents of the star. The reason for this quiet, almost gentle absorption lies in the composition of the two bodies. The Sun is a star, a colossal ball of plasma, composed almost entirely of the two lightest elements, hydrogen and helium. Our Earth, by contrast, is a rocky, terrestrial world, made of much heavier and more complex elements. The sudden influx of this foreign material, this planetary debris, would be like a contaminant poured into the star's outer layers. For a short time, this would leave a unique and fleeting signature. If there were any astronomers a safe distance away, in another star system, with telescopes powerful enough to analyze the light from this tiny patch of the Sun, they would see something extraordinary. By passing the light through a spectrograph, they could see the dark absorption lines in the spectrum, and for a few hours or days, they would see the unmistakable spectral lines of iron, of silicon, of oxygen, of magnesium elements that are not typically found in such concentrations in the Sun's outer layers. It would be a temporary chemical scar, a fleeting message written in the language of light that would say, "For a brief moment in cosmic time, a rocky planet was here, but we must contend with the humbling, difficult truth of scale. To the Sun, the entire mass of the planet Earth is a trivial, insignificant addition. It would be like a single drop of rain falling into the Pacific Ocean. The ocean does not notice. Its temperature does not change. Its currents are not altered. Its overall size remains effectively the same. So it is with the Sun. The addition of Earth's mass would do virtually nothing to it. Its internal fusion processes, the nuclear engine that has burned for billions of years, would not flicker. Its temperature would not measurably change. Its overall lifespan would not be shortened or lengthened in any meaningful way. The final, violent, and total end of our world, the stage upon which our entire species lived and died, is, to the star that gave us life, an event of almost no consequence. A momentary, insignificant ripple. We see our world as everything. It is the center of our universe, the only home we have ever known. But in the grand cosmic scheme, its final absorption into its parent star is a footnote in a story of unimaginable scale. The matter is gone, absorbed into the great furnace. But did everything about Earth vanish in that fiery, silent instant? What if something of us, some intangible echo of our existence, managed to survive? If a story is broadcast into the cosmos, but there is no one left to hear it, does it still remain a story? The physical matter of our world has been returned to the star, a brief splash in an ocean of fire. But did everything about Earth, everything that was human, vanish in that fiery, silent instant? To find the answer, we must pull our perspective away once more, leaving our solar system far behind. We drift out into the deep, cold, and silent interstellar dark, into the vast emptiness between the stars. And here, in the blackness, we can perceive something extraordinary. Moving outwards from the point where our Sun now sits alone, travelling in every direction at the speed of light, is an expanding, invisible bubble. It is a shell composed of all the electromagnetic radiation, all the radio, television, and communication signals ever generated by our civilization. At the very leading edge of this bubble are the first faint whispers of Marconi's wireless experiments, the crackle and pop of the birth of a new kind of voice. A little further in are the broadcasts of world wars, the coded messages of generals, the speeches of forgotten leaders. Deeper still, the bubble is filled with the first television signals, the music of rock and roll, the dramas and comedies that flickered in living rooms around the world. And in the most recent, innermost layers of the shell are the chaotic, shimmering signals of our digital age. The chatter of 1 billion mobile phones, the endless data streams of the internet, the navigation signals for our cars and planes. It is the complete, jumbled, and unfiltered acoustic history of humanity, a ghost of our entire modern world, still travelling outwards. The existence of this ghost is a simple consequence of the fundamental nature of light. Light, and all forms of electromagnetic radiation like radio waves, travels at a finite and constant speed, approximately 300,000 kilometers per second through a vacuum. This means that our past is not erased, it is simply speeding away from its point of origin. When we look at a star that is 10 light years away, we are seeing the light that left it 10 years ago. In the same way, an observer 10 light-years from Earth would, at this moment, be receiving the radio signals we broadcast 10 years ago. Since our first powerful broadcast began in the early 20th century, this sphere of information has been expanding. Now, in the year 2025, that sphere is approximately 125 light-years in radius, and it will continue to grow, even though its source has been extinguished. The destruction of the Earth does not stop the bubble. The message, once sent, is on its way. But this ethereal legacy is also subject to the remorseless laws of physics. The same inverse square law that focused the sun's light into a destructive blowtorch now works to dissolve our story into the void. As the bubble of information expands, its energy is spread out over a vastly larger area. The signal strength gets weaker and weaker and weaker with the square of the distance, and eventually it will fade into the background noise of the universe itself. It will become indistinguishable from the faint, ancient hiss of the cosmic microwave background radiation, the echo of the Big Bang. Is this, then, a form of immortality? A strange, melancholy legacy written in fading radio waves, carrying our stories, our art, our music, and our folly across the galaxy, long after the minds that created them have turned to stardust. It is a message in a bottle thrown into a cosmic ocean, a message that will likely never be found, and would almost certainly never be understood if it were. It is the last, faintest echo of a world that once was. Our ghost is travelling outwards. Our planet is gone. Now, let us return from this long journey of destruction. Let us open our eyes and our hearts to the world as it truly is. Take a slow, deep breath. Feel the gentle, reassuring pull of gravity holding you in your chair or in your bed. Feel the air fill your lungs. The world is not falling. The world is not burning. The world is dancing. We have walked through a nightmare of physics, a thought experiment designed to unmake our home, all to awaken now into a reality that is, by contrast, a profound and beautiful dream. Let us look at our world now, with new eyes. That gentle morning light that filters through your window is the energy from a nuclear furnace 150 million kilometers away, a furnace held at the perfect, life-giving distance. The sound of birdsong you might hear is the result of billions of years of uninterrupted evolution, a chain of life unbroken by the catastrophes we have just imagined. The simple, predictable, and beautiful arc of a sunrise is a daily reaffirmation of the most extraordinary story of all, the story of our planet's stability, a tale written by the very same laws that, in another context, would bring about our end. Let us revisit those laws, not as agents of destruction, but as the architects of our peace. The sun's gravity is not the terrible force pulling us to our doom, but the gentle, constant, and perfect tether that keeps us from spinning off into the cold, empty darkness of interstellar space. It is the anchor around which our entire existence is built. And our planet's immense orbital velocity, that incredible speed of more than 94,000 kilometers per hour, is not a momentum whose absence is catastrophic, but whose presence is the very definition of freedom and grace. It is the perfect sideways motion that balances the inward pull of gravity, allowing us to be in a perpetual state of falling and always missing. This perfect balance between gravity and velocity is what gives us our year, our seasons, and the stability that life requires. It is the core of the unbroken, celestial dance. This dance keeps our world within a very special region of our solar system, a place astronomers lovingly call the habitable zone, or more poetically, the Goldilocks zone. Just like the porridge in the fairy tale, a planet's orbit cannot be too hot, and it cannot be too cold. It must be just right. If we were much closer to the sun, our oceans would boil away, just as we saw with Venus. If we were much farther out, our oceans would freeze solid, like the icy moons of Jupiter. Our stable, nearly circular orbit keeps us perfectly within this precious, narrow, and life-sustaining ribbon of space, where liquid water, the solvent of life, can exist in abundance. We have walked through a nightmare to awaken into a miracle. The same laws of nature are at play in both scenarios. Gravity, thermodynamics, the properties of light, they are constant and unchanging. What is different is the initial condition, the perfect, delicate balance. The stability we experience every moment of our lives is not a passive, default state. It is an active, beautiful, and extraordinarily lucky balancing act, a cosmic choreography of immense energies held in a perfect, life-giving tension. This intricate balance, this perfect dance, what does it tell us about our own fragile place in the universe? The Earth's stable orbit did not just give us a safe place to live, insulated from the worst extremes of heat and cold. It gave us something far more precious, the one single ingredient that the grand, slow, and patient story of life needs more than anything else. It gave us time, an almost unimaginably deep ocean of time. Let us drift backwards through that ocean now, letting the 4.5 billion years of our planet's history wash over us. In the beginning, there is a molten, volcanic world, slowly cooling under a hazy, alien sky. Then, water condenses, and the first oceans form, a vast, sterile, chemical soup. But somewhere in that soup, perhaps in the warm darkness near a deep-sea vent, a spark ignites. The first, simplest single-celled organisms appear, tiny, fragile bubbles of life in a lifeless world. For 2 billion years, nearly half of our planet's entire history, these simple organisms are all there is. They quietly and patiently go about their work, and some of them, the cyanobacteria, begin to perform a new kind of magic. They learn to eat sunlight, and in doing so, they release a waste product, a corrosive and toxic gas called oxygen. Slowly, painstakingly, over hundreds of millions of years, they poison the old atmosphere and create the new, oxygen-rich one that we now breathe. This sets the stage for the next act. More complex cells evolve, and then, in a sudden riot of creativity called the Cambrian explosion, the world fills with an incredible diversity of multicellular life. The great story of evolution accelerates, trying out 1 billion different forms. The first fish swim in the seas. The first plants colonize the barren land. Great forests rise. Dinosaurs thunder across the continents for 150 million years, and then vanish in a flash of cosmic fire. From the ashes, the age of mammals begins, and finally, in just the last, flickering instant of geological time, a strange, bipedal ape evolves on the plains of Africa, an ape that learns to use tools, to control fire, and to look up at the stars and wonder. All of this entire, unbroken, 4.5 billion year old story, was only possible because the stage upon which it was set remained stable. Evolution by natural selection is an incredibly slow and gradual process. It relies on the accumulation of tiny, random changes over immense stretches of time. It requires a relatively predictable environment, a reliable rhythm of seasons, and a climate that, while it changes, does not swing into catastrophic extremes. Our planet's stable orbit is the guarantor of that precious, uninterrupted time. And it did not act alone. Our moon, whose destruction we imagined earlier, has been our steadfast partner in creating this stability. Its significant gravitational pull acts like a steadying hand on the Earth, keeping our planet's axial tilt, the 23.5-degree angle of its spin, from wobbling chaotically. Without the moon, scientists believe Earth's tilt would vary wildly over long timescales, leading to unimaginably severe and unpredictable ice ages and heat waves, very likely making the evolution of complex, intelligent life impossible. When you consider it all together, our existence seems to be the result of an almost absurdly long chain of cosmic coincidences. It required the right kind of star, a stable, long-lived yellow dwarf, not a violent, short-lived blue giant. It required the right distance from that star, in the narrow Goldilocks zone. It required the right size planet, large enough to hold an atmosphere with its gravity, but small enough not to become a gas giant. It required the right companion, a large moon to stabilize its axis. And it required the right chemistry, an abundance of water and carbon. We are not an inevitability of the cosmos. We are the beneficiaries of an almost impossible lottery, the inheritors of an unbroken legacy of stability and sheer, dumb luck. Every breath we take is a gift from this ancient, celestial dance. Understanding this deep, profound connection between the quiet mechanics of the cosmos and the very fact of our own lives can change the way we see the world. How do we carry this new, humbling perspective with us into the light of an ordinary day? What do you see now when you watch a sunrise? After our long journey through the darkness and the fire, after imagining the end of all things, what does this simple, daily beginning look like? Let us watch it together, with new eyes. First, there is a faint, tentative glow on the eastern horizon, a soft blush of colour painting the underside of the clouds. This growing light is not just light. It is the visible sign of our hemisphere turning back towards the nuclear furnace of our star, the source of all the energy that will power our day. As the sun's edge finally breaches the horizon, the sky above it brightens to a brilliant, impossible blue. That blue is not just a colour, it is the site of our thin, precious atmosphere, our shield against the vacuum and the hard radiation of space, scattering the sun's light in just the right way to create the colour of home. The first rays of sunlight spill across the landscape, and you can feel a gentle warmth on your skin. That warmth is a quiet reminder of the furious, million-degree star held at a perfect, safe distance of 150 million kilometers, its energy tamed by distance into a life-giving caress, rather than a scouring, vaporizing glow. The sunrise is no longer just a pretty event that marks the start of a day. It is a profound and silent drama, a daily reaffirmation of the unbroken dance. There is a well-known psychological phenomenon that our knowledge and understanding of the world changes our perception of it. To a child, a rainbow is a magical, inexplicable arc of colour. To someone who understands optics, it is the result of the refraction and dispersion of sunlight through raindrops. But does knowing the science make the rainbow less beautiful? No. For many, it does the opposite. It adds a second layer of beauty, a sense of intellectual wonder at the elegant, predictable laws of physics, to the raw, aesthetic beauty of the sight itself. Our journey tonight has been an attempt to do the same for our perception of our world. By imagining the failure of the systems that protect us, we learn to see them and to appreciate them more deeply when they are working perfectly. This is very similar to a cognitive shift that is famously reported by astronauts. They call it the overview effect. When they see the Earth from the vantage point of space, a small, fragile, and beautiful sphere of blue and white and green hanging in the vast black emptiness, they often experience a profound and transformative sense of awe. They see it not as a collection of separate countries, but as a single, interconnected, living system. Our thought experiment has been a humble attempt to induce a tiny fraction of that effect without ever having to leave the ground. By understanding the immense and ancient forces at play in our daily lives, by connecting the simple rising of the sun to the grand mechanics of the cosmos, we can cultivate a deeper, more scientifically grounded sense of mindfulness and gratitude. It is a way of seeing the miracle in the mundane. The world did not change during our journey, but perhaps we have. We have glimpsed the abyss, and in doing so, we have learned to fall more deeply in love with the solid ground beneath our feet. A simple sunrise is no longer just a sunrise. It is the quiet, daily proof of a gift of incomprehensible value. This long journey, which began with a catastrophic question, ends not in an answer, but in a feeling. It is a feeling of quiet, peaceful connection to the vast and beautiful universe in which we are so lucky to live. How do we hold on to this feeling and carry it with us into our waking lives? Listen. In the deep quiet of the night, if you can find a moment of true stillness, away from the hum of the city and the noise of your own thoughts, can you hear the turning of the world? Of course you cannot. Our planet's motion is too smooth, too vast, too constant to be perceived. Our experience of it is one of perfect stillness. And so we listen to the smaller sounds instead. The gentle sigh of the wind in the trees, the rhythmic chirping of crickets, the distant bark of a dog. Then, let your imagination expand that circle of hearing outwards. Past the sounds of the night, up into the thin, cold air of the high atmosphere, where the only sound is the whisper of the jet stream. And then further still, into the perfect vacuum that separates us from our moon, a realm of absolute and total silence. And then further, into the incomprehensible, deep, an ancient silence of interstellar space. It is a quiet so profound that it can feel frightening, like an emptiness, a great and final nothingness. But that silence is not empty. It is filled with immense, silent processes, a kind of music that you cannot hear with your ears, but that you can perhaps begin to feel with your mind. For instance, our universe is filled with something called gravitational waves. These are not sound waves, which are vibrations traveling through a medium like air. Gravitational waves are literal ripples, vibrations in the very fabric of space-time itself. They are created by the most massive and energetic events in the cosmos. Two black holes spiraling into each other, the collision of neutron stars, and even, in an incredibly subtle way, by the simple, steady motion of planets orbiting their stars. The Earth, in its constant, graceful dance around the Sun, is generating these faint, silent ripples in the cosmos. It is a true music of the spheres, an unheard vibration that carries the signature of our world's motion out into the universe at the speed of light. The cosmos is also filled with a silent, omnipresent hum of light. It is called the cosmic microwave background radiation. It is the oldest light in the universe, the faint, residual afterglow of the Big Bang, which happened some 13.8 billion years ago. This ancient light has been traveling through space ever since, cooling and stretching until it is now just a faint, cold glow in the microwave part of the spectrum. It is everywhere at once. If you were to tune an old television to a dead channel, a small percentage of that static, that hiss, is the television's antenna picking up the faint, silent echo of the creation of the universe. We live in a small, precious, and noisy pocket of sound and life within this immense and ancient silence. Our laughter, our music, our conversations, the beating of our own hearts, these are a brief and beautiful anomaly in the grand, quiet cosmos. To truly appreciate the constant, stable dance of our planet is to also learn to appreciate the profound silence it moves through. It is a silence not of absence, but of presence. It is the presence of the fundamental laws of physics, of the silent work of gravity, of the steady passage of time, and of the vast, sleeping potential of a universe that, for a fleeting moment, has produced a world that can make a sound, and a consciousness that can listen to it. We are a momentary song, sung in an ancient and silent hall. And so, our long fall home from a world of imagination has brought us back to where we began, but with a new sense of wonder for the gentle, silent music that has always surrounded us. The most extraordinary story, the most unbelievable tale of fortune and grace, is the one that happens every single day, without fail. It is the story of a sunrise, of a new season, of a world that continues its unbroken dance. After our long and sometimes frightening journey, let us end with a final, sweeping view of our Earth as it truly is, a view made all the more precious by the chaos we have imagined. See a child, sleeping safely and soundly through the night, her breath rising and falling in a rhythm of perfect trust, a trust that the world will be the same when she awakes. See a farmer, walking through his fields in the early morning light, planting seeds in the soil with a quiet confidence that the seasons will turn, that the sun will provide its warmth, and that the rains will fall, a faith built upon a foundation of billions of years of predictability. Listen to the waves lapping gently on a shore, their rhythm governed by the gravitational pull of a circling moon that holds our planet steady. And from far away, see the lights of cities begin to bloom like constellations of fireflies on the night side of a gently, slowly, gracefully turning sphere. All of these moments, all of these lives, all of this peace, and all of this hope are the direct and beautiful consequence of our stable, predictable, and precious orbit. We have spent our time together revisiting the laws of the universe, seeing them first as agents of destruction, and then as the architects of our stability. We have spoken of gravity, of orbital velocity, of the delicate balance of the Goldilocks zone, and the stabilizing hand of our moon. These concepts, taken together, are the foundation of everything we are and everything we know. The science that allows us to understand these things is not a cold or dry collection of facts and equations. It is the language that humanity has slowly, painstakingly developed to read the epic and beautiful story of the universe. It is an act of profound appreciation, a way of giving voice to our wonder, a tool that allows us to see the deep and intricate machinery behind the simple, beautiful face of reality. To study the cosmos is not to diminish its magic, but to deepen it, to understand the true and unbelievable scale of the miracle we are living within. Our journey tonight was a thought experiment. It was a ghost story told by the laws of physics, but its purpose was never to frighten, but to illuminate. Its goal was to make us fall more deeply in love with reality by showing us the staggering consequences of its absence. The universe is not, and has never been, obligated to provide us with a safe and stable home. And yet, for 4.5 billion years, it has. This is a gift of such incomprehensible value that we can barely begin to understand it. Perhaps the only appropriate response to receiving such a gift is not a fear of its loss, but a deep and quiet and abiding wonder at its presence. Thank you for joining me on this long and strange and hopefully peaceful journey. If these explorations of gentle science and quiet wonder help you find a little more peace or a deeper sense of connection to the world, please consider liking this video and subscribing to the channel. It helps others who are searching for this kind of quiet to find their way here. And I would love to know what you think. What part of this journey resonated with you the most? What everyday miracle, what small piece of this unbroken dance do you feel most grateful for? Please share your thoughts in the comments below. Your reflections are a beautiful part of this story too. Until next time, I wish you a very peaceful night and a morning filled with the soft light of a gentle and wondrous new day.